Expanded octets, compounds of period 3 elements with more than 8 electrons in the outside energy level. Some atoms can form molecules in which they have an expanded octet of electrons. Additional bonds were made after a full outer shell of electrons formed. How can this happen? It can only happen if there's another vacant suborbital the electrons could move into, and that would be a d orbital. This can only involve nonmetals as they gain electrons when they react. This cannot involve the nonmetals in the second period. There's no 2d suborbital. It can only involve the elements in period 3 and below. And in period 3, sodium to argon, silicon tends to form macromolecular structures. So really, we're only concerned with phosphorus, sulfur, and chlorine. First, chlorine. Electronic configuration 287. In the ground state, it would have the complete electronic configuration of neon, followed by 3s2, 3p5, as shown. One unpaired electron means that one covalent bond could be made, as is the case with HCl. One single bond. My electron domain geometry would be linear, as would my molecular geometry. Now, if one of those electrons in a non-bonded pair were excited into a vacant d orbital, there are 5 vacant d orbitals, only one drawn here. But I now see I've got 3 singly occupied atomic orbitals, each of which can overlap to make a covalent bond, as would be the case with ClF3. 3 bonds can form. We see from the structure that the chlorine atom still has 2 non-bonded pairs of electrons, giving me a molecular geometry of trigonal planar, an electron domain geometry of trigonal bipyramidal. If a second electron were excited from a pair of electrons, I've now got 5 singly occupied atomic orbitals. I could say 3s2, 3p3 with the 3 electrons in p suborbitals, 3d2. 5 singly occupied atomic orbitals means that 5 covalent bonds can form, and I still have a non-bonded pair. My electron domain geometry being octahedral, 6 pairs of electrons around the central atom. My molecular geometry, 5 bonded pairs giving me a square pyramidal shape. Now, I could excite that last electron here from an s orbital into a vacant d. 7 covalent bonds can now be made, as is the case with the iron ClO4-, chlorine making a double bond with 3 oxygen atoms and a single bond to a fourth, that fourth oxygen having the extra electron. Tetrahedral with respect to molecular geometry and electron domain geometry. Now for sulfur. Electronic configuration 286. In the ground state, we have 3s2, 3p4, 2 singly occupied atomic orbitals which can overlap to form 2 covalent bonds, as is the case with H2s. Tetrahedral in terms of electron domain geometry, V-shaped in terms of molecular geometry. If one of those pairs of electrons has an electron excited into a vacant d orbital, I can now make 4 covalent bonds, as we have with SF4. Trigonal bipyramidal in terms of its electron domain geometry. I won't go into the actual molecular geometry, we don't need to here. The final pair of electrons can have an electron excited into a vacant d. Now, 6 singly occupied atomic orbitals, 6 covalent bonds can be made, as we have with SF6. My shape being octahedral in terms of molecular geometry and electron domain geometry. Those 6 bonds could be single, they could be double, as we have with SO3. I still need to have 6 singly occupied atomic orbitals. I need an excited state, trigonal planar, both in terms of electron domain geometry and molecular geometry. And phosphorus, 285. Here, only the 3s orbital is full, 3s2, 3p3. Only one excited state is possible. In the ground state, 3s2, 3p3. 3 covalent bonds can form using my 3 singly occupied atomic orbitals. My molecular geometry being trigonal, pyramidal, my electron domain geometry being tetrahedral because of the non-bonded pair. If that electron in the 3s2 is excited into a vacant d, I've now got 5 singly occupied atomic orbitals, as is the case with pf5, giving me trigonal bipyramidal both in terms of molecular geometry and in terms of electron domain geometry. 5 covalent bonds can be made in phosphoric acid H3PO4. There is a double bond, but still I need that excited state 3s1, 3p3, 3d1. Tetrahedral, both in terms of molecular geometry and electron domain geometry. Covalent bond formation is always exothermic, and so it always makes the structure more stable. Phosphorus, sulfur, and chlorine atoms can invest a little energy in exciting an electron from a 3s or a 3p suborbital into a vacant 3d suborbital to form more bonds. Chlorine, group 17, we'd expect to form 1 bond. Sulfur, group 16, we'd expect to form 2. Phosphorus, group 15, we'd expect to form 3 bonds, but chlorine atoms can excite 1, 2, or 3 electrons to form 3, 5, or 7 bonds. Sulfur atoms can excite 1 or 2 electrons to form up to 4 or 6 bonds. Phosphorus atoms can excite 1 electron to form 5 bonds. In each case, we would have an expanded octet. That's it. If you got anything out of that, please hit like. Please subscribe for more content.